All right, before you click away, don't worry about the whole like 45 minute video length. Only 25 minutes of it is actual tutorial stuff, and it's separated into three sections. Timestamps are gonna be in the description and everything. And the rest of it is just me playing around with the settings, trying to find like a good thing and like showing you what they all do. So it's not as long as it looks. I apologize. Tried to make it short, but uh, without further ado, I'll let you get back to the video. Alright, hello everybody, my name is Blake447 of SilVR, and today I would like to walk you through how to use the SilVR Water Shader version 3.0, which is the newest one that I released on VRC probably like a month and a half ago. I've been slacking, but oh, 1 second. Thought I had to sneeze. Okay. Yeah, there will be timestamps in the description if you need, in case you want to zip around to like a specific topic. Most of you are probably going to have to go to Skyboxes or Resizing, which are probably going to be the only two things in the video, but I'll divide those up into specific sections. All right, without further ado, the first thing you're going to want to do is import the latest VRC SDK, and seriously, do not use an old one because you're going to want to be able to preview mirror shaders, which was added in one of the newer ones. Also, if you do, on the off chance, use a modded SDK, don't use it for this. Just use the newest version because it's not worth the trouble. But you shouldn't use modded SDK anyways. It's a wonderful way to get a virus banned. But moving on, you have the VRC SDK, and you've imported it. You're going to go into Prefabs, World, and then VRC World, drop it into here, boom. Before I forget it, I always set respawn to that. Add component, layer mods. There you go. Just something I personally do is enable jumping and object respawning. So, anyways, once you get the VRC World imported, you're going to go into VR Chat, and you will be met with a little warning down here that says the layers aren't set up properly. You're going to click a button that's going to be right here. It'll set that up. Then it will complain about collision matrix, whatever the hell those are. Click that button, sets those up as well. So once you have both of those done, you are ready to import the SilVR Water package, which I've already done just to save time. If you haven't gotten it already, you can get it right here. 36 days, yeah, about a month and a half. Not bad. But you can get it here. You can read all sorts of change logs and whatnot. I'm actually going to link you to my GitHub as well because that has documentation. You know what? Let's go over that now. Interactive water. So this is a good place to start the tutorial because everything's nice and organized. The README is not finished. I think it's been last updated like a month ago. But yeah, so you've imported this, and let's actually overview the shader. So I'm not going to go over all of the changes. I will mention them throughout the video, but there's a couple of key terms that we're going to want to focus on. There's going to be the key term, a render plane. So if I go into here, SilVR, prefab, and in order to put this down, use the second one, drag that into there, and let me collapse this. Wait a second. Oh no, you don't want to use the second one. No, wait, default quality. Yeah, you don't want to use the second one. You want to use the first one. Ah, there we go. Yes, that's what we want. All right, so the first key terminology is render plane, and that refers to this plane down here. If I drop this down, propagation rig's enabled, so this should work. So let's go ahead and 3D sphere. Move this up here. Okay. So the render plane is responsible for actually calculating the water effect and whatnot. And you can see it's got this weird blue and yellow going on. Don't worry too much about what that is, but just know that that is necessary. So let's see. What did I say about it in my GitHub? Yeah, the plane towards the bottom of the rig that propagates the ripple algorithm. Cool. Then there's something called the render camera, which I will always use to refer to this camera right here. that captures the image on the render plane and feeds it both back into the render plane and the surface up here. So let's see, what else did I use for key terms? Render plane material, there we go. So the render plane material is always going to be in SilVR materials and then either default or light, depending on which one of these you're dealing with. Default, and then it's going to be DM render plane. And I'll just to like clarify what all of those are. So this material is the render plane. And then a couple other things that I didn't mention. If you don't know what a render texture is, that would be these textures right here. That they're just textures that store these cameras inputs. So if I click on the render cam, you'll see that I have a render texture right here. That if I click on it, it'll highlight that right there. So what happens is the camera sees what's on the plane, and it stores it to this texture. Textures passed into the material, which does a bunch of calculations and is then fed into the plane, which the camera then sees and feeds it into the texture, which then puts it into the material, onto the plane, into the camera, and so on. And it just keeps on looping. And that's how the water works. But yeah, so that is all of that. So yeah, and then finally, I guess this is a new term, ray marching, or to the water tutorials. I mean, but the ray marched surfaces are these surfaces that if you click on this, you'll see that it's not actually like much of a mesh. It's you can see like this outline's going crazy because this doesn't actually use the standard rendering in like polygons. It's all calculated in screen space, which means it lets me make it actually 3D. So if I refer to the Raymarch versions, there's a Raymarch, a regular Raymarch, and a Raymarch reflective one, which has the built-in mirror shader, the VRC mirror shader built into it. So these are the Raymarch materials. This is the render material, render cam, render plane, and then render textures. So all terminology, which took up way longer than I hoped it would, but moving on. With terminology aside, let's cover probably the single thing that I get asked most about, skyboxes. So you'll notice that I have like this skybox, and I can actually make it a little bit more apparent by changing one of these settings, fake AO alpha baseline. Turn that up. Yes. Turn the matte all the way down, and you can see the skybox a lot better. So we have this skybox, and it's probably not what you're using in your world, so we want to change that. So the easiest cases are if your skybox, here, let me duplicate this. So there's three main kinds of skyboxes. There's cube maps, equal rectangular, and then there's spherical. So if I go ahead and change these settings, default to the, and then hit apply. So an equal rectangular skybox is like this one, so that you see it's like that standard like YouTube 360 video type thing. Those are equal rectangular videos. A cube map is more of this kind of layout, and then spherical I wouldn't worry about. Oh, here's the latitude longitude equal rectangular one. But yeah, so if you have one of these two, or a spherical one for that matter, it's easy. You just click on this, set cube, latitude, longitude, mirrored ball, or 6 frame, play around with it if you don't know. And then I always limit this to 1024 and hit apply, because there's usually not much of a quality change. Yep, and there we go. So that will turn either of any of those three into a cube map like that, and then you can create a material. And I'm just going to call this sky. Skybox, cube map, and then I think I want to use that one. And boom, it replaces the skybox like that. Although if you don't see it, you might have to hit this button, which will change it from that skybox to like a grayish color, or from the grayish color to the skybox. So now, what if you have, and then I don't need these anymore. So now, what if you have a 6-sided skybox? Well, so let's say you downloaded your skybox from, like, say, this website. This is one that I just always use for the examples. and it gives you 6 images instead of a cube map. Well, I hate to break it to you, but you're probably going to want to go into some kind of image editing software, and you're going to actually want to turn it into a cube map. And there's a couple reasons why you might want to do this. One of the big ones is that will get typically, if you have a skybox like this, it will have like these sharp edges on the side, but putting it into a cube map will fix that. So what I'm going to do is I'm going to open one of them, and I have it set to double click opening. When I double click an image, it opens GIMP, but you might need to do that manually. You can import one, then open them as layers, and I'm going to open all of these at once. And now I'm going to make the aspect ratios the same thing as this. So I want it 4 squares across and 3 tall. So image, canvas size, 400% across, 300% tall. Boom. Zoom out. And then, let's see, this one is the copy. So I'm going to mark it with a paint. And then the rest of them I'm just going to get lined up. So get all these off of each other. Let's see, this one's obviously the bottom, this one's obviously the top. Let's see, this one is going to go right there. This looks like it goes here, and this one looks like it goes there, which means this one fits right there. And then typically what I just do is I take the zoom tool and I zoom in, fit that perfectly, and yeah. So say if I zoom in this one here, move that to right there, move that to right there. If you're having trouble lining it up properly, because these are going to be like seamless, so once you have like these two, if you wanted to line this one up on this side, it would be a little hard to see. All you have to do is just disable one, and then let's see, play around. Oh, that works. And then just line it up perfectly. So skipping all of this because I have already done it for a previous attempt at the shot. You're going to add a new layer, paint it black. That's probably not necessary. And then, but I did it anyways. And file export as just Rocky Valley, and then you're going to find wherever your project is. I think I exported this one to the desktop last time, so let me go ahead and grab that. Desktop, name Rocky, or what did I call it? Or Rocky Valley right here. So now you're going to import that. Oh, you might need to rotate some of them, so just kind of play around with it. But then again, same process as before. Cube map, set it to mapping 6 frame layout, limit it to 1024, hit apply, and you have a cube map. So now let's go ahead and replace this skybox with that. And we have this slightly low resolution area, but that's all right. I'm also going to create a plane on the floor, just so it feels like there'd be something to walk on. There. So we have this plane, we have the cube map, and we have the water in. But you might notice that the water doesn't quite reflect it. So you have to take this cube map and you have to actually input it into some of the materials. If I go into SilVR materials, there's actually going to be 2 sections that we need to change. We need to change them in default. We need to change them in light. So I can actually select to show both of them. Ignore that pink thing. And now there's several materials that we want to change it in. DM top and DM bottom stand for default material, bottom and top. These are the same kinds of materials, so you can change them together, set both of them as sky. So now, let's see, DM Ray March is another one that you're going to need to change. There you go. And then I highly recommend changing this one as well, just so it doesn't import more than one cube map and take up extra memory. Finally, LM top and LM bottom are the lower quality versions, so I'm going to go ahead and change those as well. So now you can see that the reflections actually work out properly now. The sun's right there over here, and the sun's right here there. And everything is working as it should. So that's how you change the reflection. Okay. Yeah, so skyboxes aside, what we're going to want to do next is we're going to want to cover how to change the size and the aspect ratio of that. And I'll do that in one fell swoop. So what I want to do, just for the purpose of the tutorial, is I'm going to make it so that, say, this one is twice as wide. So let's make this plane too wide. And then, I don't know, let's say some weird number like 1.5 times as tall, 1.5 times as long. So we're going to make it into this big, wide pool, and holy cow, I am going to turn that reflectivity down. Default, ray march, turn the matte up so that it's not like blinding. There we go. So the first thing that you're going to want to do is you're going to click on desurface, and you're going to change the scale of this. So it looks like you can kind of eyeball it and then kind of see if you guessed right. It's easier to look from directly above and then turn perspective off. So it actually doesn't look like it's centered completely properly, but default quality. What's moved is the wait, no, the plane's on center. Whatever, it's close enough for me. That is bothering me. Are all of them like that, or is that just slightly offset? No, all of them are like that. Desurface got moved somehow. Go ahead and zero that out. If that's the same for you, I highly recommend doing the same thing. But desurface, and then let's go back to just the ray march. I'll go over what all of these are in a little bit, but for now, you're just going to change all of them in one fell swoop with desurface. And you might have noticed that it's actually just 5 times whatever the size of this plane is. So 5 times 1.5 is 7.5. 5 times 2 is 10, and it lined up perfectly. So there we go. So now the big problem is this doesn't completely line up. And the reason is because I kind of skipped a step when I was explaining it. We need this camera to also pass in some information into this to work properly. So but in order to change this camera, as I said before, we have to change the aspect ratio of the render textures. Ooh, and actually, yeah, whatever. So yeah, here's where things get unfortunately more complicated than I intended them to be. So let's see, if I go into here, basically, let me paint you an example. Let's do a really extreme example and say we want the water's resolution to be something like 2 pixels tall and 2 pixels wide. No, that doesn't really make much sense. So let's say we have some image with 2 pixels wide and 3 pixels tall. But then the plane, for some reason to fit perfectly, it has to be some 2 units wide, but then 1, 2, 3, and then a half. So in this case, we could fix this by simply increasing the resolution of the water, but there's going to be some cases where that's not possible without turning it into a ridiculous number. So what we're actually going to want to do is we're going to get a rough idea of changing the size of the plane, and then we're going to use that to find an exact resolution for pixels. And we're going to convert that back into the size for the plane. These are the pixels, sorry. We're going to convert that back into the size of the plane. So I actually should change this so that it's like, say, render plane. So say I want this to be like 7.342 or something. So 10 by 7.342, and then we're going to leave it like that as is for now. So first off, let's start with the first step, and let's see how many pixels do we want per meter. So, per meter. So what I typically do is I typically do like around 192, but this is a larger one, so I'm actually going to tune it down to 144. So that means for each one of these units that I have, I'm going to have 144 pixels along that axis. Now be careful with this because the resolution makes a huge impact on performance, so don't make it too crazy. In fact, I would actually, you know what, I'm going to be a good example, and I'm actually going to say I want 96 pixels per meter. So 96 pixels per meter, 10 meters across. I don't think I need to tell you the math for that. So 96 times 10 is going to be 960. So, and that's going to correspond to the x direction. So let's go ahead and change that to 960. Oh, look at that. And 960. Look at that. But now we're going to get to 96 times the other size of the surface. So z corresponds to the y-axis, so we're going to get 96 times 700 or 7.342 times 7.342. There we go. And we look at that. We have a decimal. So if any of you can tell me what resolution you would want to turn this up to make this a whole number, feel free to, but you're probably going to crash your computer doing that. So the solution for us here is to just round it up to 705. So I'm going to make this 705, and I'm going to make this 705. So that changes the resolution of these two render textures, but now we also need to we need to change the plane to match. So we can only change the pixels a certain amount, so we need to change the plane because that's what we have more control of. And the way that we do that is we take the original pixel density. I'm not going to need to change the x because that's not what I had to round. But whatever you round, you're going to have to do this process with. So we decided on 96 pixels per meter. So let's divide 705 by 96 to get how many meters we want. Turns out we want this number right here, 7.34375. So I'm going to go to surface, and I'm going to change that to 7.34375. Just like that, 34375. Perfect. And then, so now that we have that size, we're actually going to take this, and we're going to copy it. We're going to go into the render plane queue, and you're going to make these dimensions match. Finally, you're going to also take the Z, so I copied it again, even though I didn't have to. I'm going to do render cam and dcam in. I'm going to paste this to be the same size. To update all the cameras for sure, I'm going to close this out, reactivate it, and then everything's working as it should. Now let's go over to the sides. All right, perfect. And then there is one more thing that you're going to have to do because basically, let's see, we're going to go into all of the materials and we're going to tell the materials what the resolution of the image was so that it knows to use the proper aspect ratios. What's going on over there? I actually can't remember if this is necessary, but here, let's see. Oh yeah, so you can see how that's not exactly a circle when it comes out here, it's more of an oval. So that's what this is going to fix. And it does typically correspond properly. So yeah, we have image width and height. So this is actually going to be 960. And then what did we assume the other one was? Oh, it was 705, wasn't it? So 705. So that should actually bring it pretty close. The distortion. Yeah, and here you can see to make the distortion work better, I kind of subsampled that. Don't do that because I have a wave size modifier now. So that's the proper way to do that. So 960, and then 705, and then I would actually turn this, not refraction, I'd actually turn this down to like 0.25. And we're just gonna keep on doing this. Don't be alarmed that I accidentally called this image resolution twice. It should be ordered the same. So that should still be 705, and then this needs to be 705. And then it also has, this is the most important one to do it in is the DM render plane. And then finally DM top, 960 and 705. So now let's go ahead and take our sphere and test to make sure that this is rippling in a nice spherical manner or circular manner. And look at that. That's a damn good circle if I do say so myself. All right, so now that that is out of the way, I'm going to try to remember if there's anything else to do, but I don't think there is. So you might have noticed that we never did that for the light quality, and if you go into here, you'll see that those are all square. You will have to repeat that process, although there's slightly fewer things to do, and you can reuse the values. But so that covers resizing and aspect ratios, both in one. So we've done skybox, aspect ratios. Now, I'm not going to do collision masking in this video. I actually want to save it for a separate one because I'm still working on a good system to do that. But I do want to go over all of the options and all of the different stuff we have here because now it's kind of getting a little bit out of hand and there's a lot of things to think about. So if you want to play with this yourself, feel free to. But I'm going to do it, and I'm going to move my headset, which I'm using as my microphone, so that I can better see the inspector tab. So first off, let's cover the ray march surface. So I'm not going to explain what ray marching is. I might have a link in the description that covers it. But the biggest difference, the biggest advantage that this offers over the previous version of my shader is that you actually get these three-dimensional displacements that are much smoother than if you were using vertex displacement, which just doesn't look nearly as good. So, boom, we have that, and it does cause some like weird artifacting every now and then, but that's all right. So, so the material that controls this is DM Raymarched, and you can see there's a lot of stuff. Here, let me turn the mat up a little bit, maybe. All right, so we have, the first thing we have is the directional alpha. So basically what this does is, if you see here, this is all nice and evenly reflective. But if I turn the alpha baseline down and then the directional alpha up, so you can see that this is much more reflective than if I look down. So yeah, so that was to try to give it like that more look. Like when you're looking at a lake, like if you look straight down, you can see it, but then if you look out across and look for fish that are far away, you can't really see it as well. So that's what this was supposed to simulate, but I'm not sure how physically accurate it is. It's just a little option. If you don't like it, turn the directional alpha all the way down, and then this just works like a basic transparency slider. So with the next one, you also have matte. So the matte will slowly interpolate between perfect reflection and then some color tint. And that color tint will be controlled by this little thing right here. So there we go. So let's go ahead and turn the matte down. And then if you don't want a color tint, white would be the way to go. And then it's like, or no, if you don't want a color tint, I think, yeah, black would be the way to go. So directional alpha, nope, that's not what I wanted to do. And then we can turn the matte up and down. Yeah. This one has a lot of settings, so playing around with it is definitely like a must because I still haven't quite found something that I like, that I found to get it or to get it how I like it. I don't have like a preferred set of settings yet, but so just play around with it. Let's see. And then we have this fake ambient occlusion. So let me turn the matte all the way down, change the color to all the way white so that we can see it a bit better. And then directional alpha off. All right, so now if I create a ripple here, you can see, wow, that's, okay, that was a bad idea for actually showing anything. Do I have the ambient occlusion strength all the way up? AO color tint, fake, yeah. So if I turn this all the way up, you can see that basically when the water depresses, it will become a little bit darker, which I think is actually the opposite of what happens in real life. But I'm not sure. I implemented this to try to get like a little slight change in like how it looks like 3D. Like you can kind of see that's 3D now, but I prefer to have this like pretty much way down, like just as a nice little sort of side effect to it that you can barely even notice. I've seen this shader used in a couple worlds, and I think that they have that setting too high. I probably should have set the cap lower, but yeah, it's not important. It's all part of personal preference. Let's see, DM Raymarch. So yeah, this is the control for the distortion. I wouldn't actually mess around with these too much. I think they're just fine. The wave height. Let's see. What if I turn that way up? Yeah, so if I turn that way up, we have like it's doing some weird stuff right now. Uh, you can definitely see the 3D now, but you can also see all the jitteriness and the noise to it. But that controls how tall the waves are. Don't set it to whatever the hell I just set it to. I think I set it to almost 30. I had it set at 1.5 as the default, and that's typically pretty good. I highly, if you want to use the flat one, don't set that to 0. That is a huge waste of resources because this is a lot more performance heavy. But yeah, this smoothing I have all the way up, but it doesn't do a whole lot. Epsilon is a little bit more technical. It's basically the maximum distance away from or the minimum distance that a point has to be from the surface to be considered a hit. Although it doesn't change. It doesn't change that much as far as I know. So this is a good value. Average distance multiplier. Oh, so these are like all sorts of distance checks. So for it modifies like how much or how far across it checks normals. Again, I highly recommend just leaving these where they are. And the light direction, I'm not using directional lights for this. I'm actually using like a little sliders to set this. It'll normalize it. So play around with that until you get it how you like, and then just sort of keep it there. If you change the lighting, you're gonna need to change these settings too. But uh, yeah, and then the light step length. What this is basically on top of ray marching the surface, I'm also ray marching the lighting, or more along the lines of just doing like a quick and dirty ray trace. So light comes in, it hits from this point, and then what it does is it bounces off, and it checks to see if the wave is in here. Let me actually disable the propagation rig so that this doesn't update on me, so that I can leave this nice little wave right here. So basically what it does is the light step length will actually change how far it steps. So if you set this to 0, it'll always think that it's dark. And then the light density, oh, I'm changing the wrong surface. That's why it's not doing anything. Yeah, this controls like how quickly it makes it dark. Like you can see all the individual steps in there. If I turn this like way down, we get like some like, oh, that's right, I stopped propagating it. But yeah, we get that D-ray march, and let's go ahead and turn that back up. And then I like it, just a nice subtle change right about there. Light step length, yeah, that did something. This changes again how far it steps. Ooh, I actually like it being a bit lower like that. Let's see. There we go. And this means that we can remove the ambient, or we can turn the ambient occlusion down. Like there you see that section's like a lot deeper, so it'll be a bit darker. So make ambient occlusion. Oh, and you can also tint the ambient occlusion as well. Like you could even tint it white if you want. Actually, that's a nice light density. So let's go ahead and start re-stimulating and see what this looks like. Propagation rig. Yeah, see, even that, I would say the ambient occlusion's a little too high for my taste. Actually, right about there. There we go. And the settings that you want are like heavily going to depend on what skybox you have as well. Like that's kind of my favorite thing about this shader is seeing how it looks with different skyboxes. But yeah. So that's enough for the DM Ray March. So I'm just going to disable that one, and I'm going to cover Reflective Ray March, which uses the built-in VRC mirror script. And here you see that it's actually using like a VRC mirror. So if I take this, you can actually see the cube or the sphere in here. You'd also be able to see any terrain. And even though we never assigned a cube map, you can see the reflection of this cube map because, it's a mirror. But this one has pretty much the same settings as the other one, DM Reflective. Like if I swap between them, you can see they're all the same parameters, except for the like reflection goes off. It changes to the mirror color instead of the cube map sample color. So there's that. So then with those aside, we have the top the bottom, and the distortion, which are all part of the same setup. So this one is the old type of water setup. So it's all like that. And let's see, did I have the flat mirror on? Where's the flat mirror? Yeah, so you can add a VRC mirror right underneath it. And it's pretty much and then you can have like the same effects as this. Let's see, and let me make sure that the distortion's on, because I actually don't see it right here. I do not see what's wrong with the distortion? Hold on, I'm gonna feel really embarrassed if I use the wrong prefab. Water rig 1, what does that look like? Flat mirror, default quality, cam in, legacy. No, this one doesn't have, this one has the flat mirror, but whatever. Materials, default, and then, wait, I have a material for the flat mirror. Mirror cutout. Ah, okay, so, anyways, it looks like I've included a shader for that, but I wouldn't worry about it too much. Trying to figure out why the distortion isn't working very well. If I disable that, oh no, it's definitely working. It just needs to be turned up. Oh wait, because I turned this wave modifier there. So let's turn the refraction up a little bit. Yeah, there we go. That's refracting now. All right, so distortion, I guess I might as well start with covering this. Distortion, we got image width, image height, self-explanatory. Wave size modifier changes like how big you want the distortion from the waves to be. Refraction is the strength of the refraction. And then all this stuff is other stuff that I don't completely understand because this is mostly somebody else's shader. But let's see. Then we have the DM top and the DM bottom, which are just like the old style ones. You can change the alpha to what you want. I don't think you can actually color tint these ones yet. But there's transparency masks, which I would like to cover in a different video, but yeah. And then DM render plane is just the same as before. This one I would actually recommend not touching. You have options here, but they don't do they. I always keep them at like my recommended settings. So let me see if I can play around with the DM top and the DM bottom, try to make them look a little better, because I'm not 100% on board with how their appearance right now. So I think I actually want the wave size larger. Yeah, that's a bit more how I like it. Yeah, so the waves are a little bit bigger, and I know that didn't explain everything too much, but you're gonna have to play around with it. That's the basics. I'll put another video for collision masking, which is probably my favorite part of, which is probably what I think makes the biggest difference. Just because it's like kind of it's just so good to see like it bounce off like this object that you just wouldn't expect it to, and just like peels off the edges. Here, let me show you what I'm talking about. I create a 3D object, not a sphere. I need a cube for it to create 3D object cube. Reset this. And I'm going to set this to be the reflective ray march. Like, it's just so good to just watch it peel off the. Oh, you can't really see it that well right there because everything's like all white. Just the regular ray march should be good. There we go. Yeah, just to see it like peel off the edge. It's one of my favorite things to sit and do. Huh. Right. That was a terrible tutorial. Hope you enjoyed or at least know what the hell to do now. I will hopefully see you in another video covering collision masking once I figure out a good method for that.